Hi everyone, in this video we are going to talk about another data structure that's called priority queue, and the underlying data structure is called a heap. And what you can do with priority queue, you can push data, you can pop data, but according to a certain priority, okay? And that priority we have to tell what is the criteria for this priority. For example, if I make a queue of numbers and I push certain numbers out of it, let's say something like this, and I say the number which has a higher value will have a higher priority. Okay, so if I pop out numbers, the first number I will get is 6, so 6 goes out of the queue. The next number I will get is 5 because a higher number has a higher priority. Okay, the next number that I will get is a 3, the next number that I will get is a 2, and next number will be 1, and finally queue will be empty. Okay, so it's not actually implemented as a queue, but it's actually implemented as a heap. Okay, so if you want to push one element inside the priority queue, this takes order of log n time. Okay, and that is the insert operation in the heap. If you want to remove an element, that is also going to take order of log n time. And if you just want to see what is the element that is there, okay, so heap is implemented something like this. It's implemented as a complete binary tree, and it has a heap order property. Okay, so if you want to get the next element, so next element lies on the top of the tree, and this element, if you want to see, it's given by a method called top, and this takes order 1 time. Okay, so log n time is also pretty fast. If you have, let's say, 10 power 10 elements, then log of 10 per 10 is just 10. Okay, in just 10 steps you can get the you can push an element and you can pop an element. Okay, and the reason why this is log n, because the height of the heap is log n. Okay, you are doing operations in this complete binary tree with heap order property, and this just takes log n time. So that's why these operations, push, pop and top, they take log n time. Okay, so let's discuss the priority queue STL implementation, and these are the most important methods that we are going to cover. And one more method that we can see is we can check if the heap is empty or not. Okay, empty or not. So let's dive into the implementation. So I can say this is also part of queue header file, and I can make a priority queue like this, and this is of the type int, and I can say let's call it pq, and we can add some numbers in this. I equals to 1, or let's take input those numbers. Okay, so int number, scene number, and I say okay, pq dot push number. Okay, so this priority queue class is a part of queue header file. So queue header file contains the queue class, it also contains the priority queue class. Okay, so this push method will insert the elements in the heap, and complexity of each insertion is O of log n, where n is the number of elements present in that heap at that time. Okay, okay, let's try to remove the elements from the heap. So I can say while this priority queue is not empty, so we can call the empty method, and we can extract the first element that is on the top of heap by using the top method. Okay, and we can pop it. That's it. So let's give in some input. Let's have 5 elements, and these elements are 1, 10, 7, 4, 3. Let's run the code. Oh, okay, n should be given as input here. Yeah, so int n, scene n, that we missed. So you can see the element that has the highest priority, it's coming in the first position, followed by 7, 4 and 1. So by default, this type of a priority queue is based out of a max heap. where you get the maximum element first. Okay, you can also convert this priority queue into a min heap by passing a inbuilt comparator that's called greater int. Okay, so what I'm going to do, we are going to reverse the comparison by passing this comparator that is also provided by STL. So you have to pass in two parameters here. One parameter is called vector int and another is the comparison that's called greater int. Okay, so let's run the code and this will change the priority. Okay, so from the maximum element now you will have minimum element in the beginning. So this is how you can build a priority queue, and this is a min priority queue. Okay, and by default this is a max priority queue. Okay, so don't worry if you do not understand heap, still you can use standard template library. That's the good thing. The only thing is you should know what is the complexity of each operation and in what type of problems you have to use it. So that's all for this video, and thanks a lot.